In this chapter, we're going to talk about the next step in object-oriented programming, and that's working with inheritance. To explain the concept of inheritance, I'm going to have to write a few notes. So I'm going to start a notepad file. Inheritance is used to implement what's called an ISA relationship between objects. For example, car is a vehicle. Manager is a employee. Now the grammar is not perfect there, but you get the idea. With inheritance, we can create what's called a base class, such as an employee class or a vehicle class. And we can define that class to have a certain set of attributes and behaviors. Here I'm talking more in terms of abstract data types. Then we can create what's called a derived class from that base class that inherits those attributes and behaviors that are defined for the base class and then add extra functionality to the derived class. So for example, we might define a vehicle as something that has wheels. And then we can say a car is a more specific vehicle that has 4 wheels. An employee is a person who works for a company and has certain attributes such as name, an ID, department they work in, and a salary, or maybe they're hourly. And then we can specialize a type of employee as a manager, derive the concept of manager from employee, and include extra attributes and behaviors, such as a manager may not be able to earn overtime. A manager supervises other employees. And yet, even though the manager has these extra powers, they are still considered to be a type of employee. A manager is an employee. Last example, and this is the one we're going to demonstrate in code, rectangle is a shape. Shapes have attributes, but they're fairly ambiguous. In the example I'm going to provide in a moment, a shape is defined as having XY coordinates. So we're thinking of a shape somewhere on the plane as having at least a single XY coordinate. And then the rectangle can be derived from that shape and provide other attributes, such as having a width and a height. Let's go from these concepts to a Python example. So we're going to create a program called rectangle.py. The first thing we're going to do is define our shape class. So we're going to define a shape to have 2 fields, an X coordinate and a Y coordinate. We'll define a toString method that will just print out the X and Y position of a shape. And then we'll define a method called move, which we can use to move shapes around. So this first line moves it on the X axis, and then this next line moves the shape on its Y axis. There's more we can do to define a shape, but that's good enough for now. We want to create the rectangle class as inheriting from shape. So the way we do that is we put the base class in as an argument. Think of it like a function call. And the base class is an argument to the derived class. And what we're saying is we're saying class rectangle inherits from class shape. So the first thing we're going to do is write the constructor. Now, when we're defining the constructor for a derived class, one of the things we have to do is call the base class constructor. That's the only properly way to create a derived object. So here's our call first to the base class constructor. It looks kind of odd, but you'll see what's happening is we don't have to rewrite our code. We inherit this method from the shape class, so we can simply call it with the proper parameters, and this code will be executed. Then the rest of our constructor will define. I have length in the parameter list, but that's supposed to be height, so let me fix that. There we go. Now we also need to redefine the toString method. So the first thing we do is we're going to create a return string that will return the state of this object. And to do that, we're going to call the toString method for the base class first. Then we're going to add to it So that's going to be a plus equal to concatenate to the current value. Then we'll drop down to the next line right here to show the rest of it. And then when we're finished, we simply return our return string, and we're done. Now, that's all we have to do to define rectangle. We can use the move method directly from the base class shape. We don't have to specify it at all in our derived class if we're going to use it as is, and it should work just fine. So let's try that by creating a rectangle, x coordinate of 5, y coordinate of 10, width of 8, height of 9. Display it using toString. Then let's move it to new x and y coordinates, and then print it again. So let's save it. Bring it back up. Type the code. We need a space there before we start with, but other than that, you see how it works. Let me go add that in real quick while we review. There. And right here, add some spaces. Okay. So to review very briefly, we can derive a class from a base class using inheritance. When we do that, we're able to call methods from the base class in our derived class, as well as add our own code to a method to accommodate the derived class. If we don't need to make any changes to a method, though, like with move, we can use it as is, as we did in this example where we created a rectangle, then moved it, even though if you look at the code for rectangle, we did not include any code for move in that definition. So that wraps up this first lesson on inheritance, and we'll look at some further concepts in the second lesson of this chapter.